All right, so we in class just looked at how we change fractions to decimals to percents and back and forth and between those three ways of representing the same number. And now we're going to look at how we use percents. So percents are a way to compare things, and if we can get that common denominator of 100, then it's very easy for us to compare one math test to another math test. How did you do on this math test versus how did you do on this math test? What does it mean to get 5 out of 10 versus what does it mean to get 12 out of 24? Is it the same? Is it different? How does that compare? And by having a common denominator of 100 with those percents, we can start comparing things. So we're going to be looking at how to use those today. But first it's important to talk about the language that we're going to be using in these problems. And so we're going to be looking at words, which sounds a lot like saying word. So we're looking at words. And so the word is, in math speak, in math problems that you see in word problems, the word is typically means equals. And so when we're looking at that, I don't think I have anything here to, no. When we're looking at that, we use the word is, or when we see the word is, it means equals. So we're looking at word problems. If it says this is the same as that, we say they're equal to each other. Now, because in English we have past tense words, we have other forms of the same word, you might also see were or was. So this was the same as that. These two things were equal. And so is, were, and was are three words that we're going to notice, and we're going to say, oh yeah, that means they're equal. So we can use an equal sign. Of, in math, typically when we see the word of, it means to multiply. And so we're looking at some word problems today. We're going to be seeing these words, is and of, and were and was. And we're going to try and figure out how to set up some equations based on those word problems. Okay, first example. What percent of 18 is 12? Round to the nearest tenth of a percent. So what percent? We don't know. So I'm going to use P as my percent. Of, hey, that's one of our words. What percent of? Of means multiplication. 18 is, hey, is, we know that word is means equals in math speak. 12. I've got an equation. I can solve that equation. And so if I want to solve for P, if I want to get my P all by itself, which sounds a little gross, but if I want to get my P all by itself, I'm going to divide both sides by 18. Divide both sides by 18. And you've got a couple options here. You can certainly write it as a fraction. You can reduce it if you really wanted to. But somehow we have to get this into a percent. So if I divide, I'm going to put it as a decimal, 0.666 repeating. Now that's not a percent. The question says what percent of 18 is 12. I've got that 0.66 is a decimal, is a number. It's not, or is a decimal number. It's not a percent. So I have to change that. But we talked about how to do that in class, where we just move the decimal over, and I'm going to get 66.6 repeating. Remember, those sixes don't disappear. They just keep on going. And so it would be 66.6 repeating percent. However, of course, I look back at the question, round to the nearest tenth of a percent. And so I am going to have to round. It would not be 66.6 repeating anymore. If I round to the nearest tenth of a percent, I'm going to get 66.7%. So using those words is and of, I can set up an equation, solve for P, and I have to make sure that I change my answer to a percent if it's asking for a percent. So look at another one. What percent of 14 is 56? And we don't know the percent. Of is multiplication. 14 is equals 56. All right, I have an equation. I can solve both sides. I can divide both sides, by 14. If I do 56 divided by 14, I get 4. So P equals 4. But it's not 4%. Remember, that's a decimal. 4.0. 4.00. What percent of 14 is 56? Well, 14 is a lot less than 56. And so 56 is 4 times as big. That's 400%. If it's 4 times as big, that's 400% bigger. If somebody is 100% your size, they're the same. If somebody is 200% your size, they're twice as big. If somebody is 400% your size, they're 4 times as big. So 56 is 400% of 14. We've got our answer. Be careful. If you are using percents, before you can actually do any calculations, add, subtract, well, multiply or divide, which is really what we're kind of working on here, it has to be changed to a decimal or a fraction. And that's really important that we change it to either a decimal or a fraction before we do any changing, or before we do any manipulation of it, before we do any calculations with it. So we're really looking right now at the decimals. In the second video, you'll see fractions. Okay, 90% of what number is 120? And so again, here's a percent, but I need to change that. I either need to change it into a fraction or a decimal. At this point, I'm going to change it to a decimal, mostly because it's a little bit easier. I don't have to reduce or any of that. I just move the decimal to the left, and I get 0.90 or 0.9 of times what number? We don't know, so I'm going to use n for number, is equals 120. All right, I've got an equation. So again, I'm going to go back here to this big warning, beep, beep, warning. You must convert the percent to a decimal or a fraction before doing any calculations with it. So before we can do divide both sides by this number to get n by itself, we have to change 90% to a decimal or a fraction. But I'm going to go with a decimal because calculators like decimals. So we divide both sides by 0.9, divide both sides by 0.9, and 120 divided by 0.9, we're going to get 133.3 repeating, but it says round to the nearest tenth. So 0.3. And that is not a percent. Because remember, the question said what number? N is a number. It's not a percent, so don't put a percent by it. We already have a percent, 90%. We wanted to know a number. So my number is just 133.3. Next one, student. Hey, you're a student. A student answered 32 questions correctly and 8 incorrectly. What percent of the questions were answered correctly? All right, let's look. So a student answered 32 questions correctly and 8 incorrectly. What percent? I don't know. P. Of times the questions. How many questions were there? There were not 32 questions. A student answered 32 questions correctly and 8 incorrectly. So how many questions were there? Well, there were 40 questions. So 40 questions. So what percent? We don't know. Of times the questions. There were 40 questions. Were, and again I mentioned earlier it's not is in this case because it's past tense. It would be wrong to say what percent of the questions is answered correctly. That would be like BFG speak, if you've ever read the book BFG. Answered correctly. So were equals answered correctly. We know that one. They answered 8 correctly. Now I have an equation. And so I can solve this equation. I can divide both sides by 40. Divide both sides by 40. 8 divided by 40. I'm going to get 0.2. Which again is a decimal, not a percent. And so I need to move the decimal point 2 to the right and get that P equals 20%. So how many answers were answered correctly? Oh, you know what? I apologize. Now, see, I hope you're writing a note to yourself saying, Mr. G, you did something wrong. I found what percent they answered incorrectly because I was not reading it carefully enough. Incorrectly. 8, they answered 8 incorrectly. The question asked, how many did they answer correctly? So I did a little bit backwards, but let's use that. So I found how many were incorrect. If they answered 20% incorrectly, and 100% is all of it, 100% is all of it, minus the 20% that they got wrong, that gives us 80% correct. So it should be 80% correct. Let me change a few things in my work to show that, to show what it should be. So 100%, I'm going to put that back down here, minus 20. We should have then 80% correct. But let me do it again to show the correct way to do it then. So it should have been P times 40 equals 32, because I got 32 correct. Divide both sides by 40. We get that p equals 0.8. If I move the decimal 2 to the right, I end up with p equals 80%. And sure enough, that does work out the way it's supposed to. So, I had to be careful with that one. I hope you were writing a note to yourself, Mr. Gustafson, you were doing this wrong. But it happens, we fixed it, and we got the right answer, 80% correct. Okay, we're going to deal with fractions at a different time. And so what I want you to do is, you can pause it now, you can look at your other notes, and we'll go into a new note in just a little bit.